Welcome. My name is Trisha Morris, and I would like to welcome you to my channel, Mathematics Simplex, where you will be able to view videos you might find difficult in your mathematics class. Please don't forget to subscribe. Also, like my video. Okay, I'll be starting with product rule. Now, the product rule, as the name suggests, it is when two functions are beside each other and it's looking as if it multiplies. Now, let me explain the formula. The order doesn't matter. So I can have uv prime plus vu prime, or we can have u prime v plus v prime u. So order doesn't matter. Now, say for example, we have x squared cos x. So I'm just going to say let u be equal to x squared and v be equal to cos x. Now, I have already gone through the rules: derivative of x squared, the derivative of cos x. Now we know that the derivative of x squared, so u prime means the derivative, is 2x, while the derivative of cos x is minus sin x. After doing this, we can go ahead and substitute in either the first formula or the second. It really doesn't matter. What some students like to do is just do a cross multiply and attach them together. So x squared times minus sin x. So you have x squared times minus sin x. Then we have 2x times cos x, so it's plus cos x times 2x. Now simplifying this, I'm just going to put the minus in front of the x squared. So rearranging, you have minus x squared sin x, and rearranging, because we're used to having the 2x in front of the cos x. And this is the derivative of x squared cos x. So if we have x cubed and x squared minus 1, there are two ways to do this. First way, we can, without the product rule, expand. So x squared gives you x to the fifth. X cubed times negative 1 gives you minus x to the 3. Then differentiate this, we have 5x to the 4th minus 3x squared. So that is one way. The next way, because we have two functions being side by side, we can assign one to be u, so I assign x cubed to be u, and then the next to be v, so I have x squared minus 1 to be v. So we differentiate and we arrive at 3x squared. Differentiate v, so we have 2x. Now cross multiply. So the derivative of this function, it's x cubed times 2x u times v prime. So x cubed times 2x plus 3x squared times x squared minus 1. So v times u prime. So we have x squared minus 1 times 3x squared. Now from indices, we know that we have a power 1 here. So we add the power when we multiply. So we have 2x to the fourth. Then multiplying 3x squared times x squared, it is going to give you plus 3x to the fourth. Then minus 1 times 3x squared gives you minus 3x squared. And then simplifying this, 3x to the fourth plus 2x to the fourth gives you 5x to the fourth minus 3x squared. So realize if we use product rule in this case, or we expand the bracket then differentiate, we are still going to arrive at the same thing. Now for quotient rule, the order matters. So we always assign the numerator to be u and the denominator to be v at all times. We assign the numerator to be u and the denominator to be v. Then we have the formula is v squared over v u prime minus u v prime. So when we have something like x squared over cos x, it's in a fraction form. So we have to apply the quotient rule. So the numerator at all times will be u, and the denominator at all times will be v. So if I'm going to go ahead and differentiate this, I know u prime, my u prime means I differentiate x squared and arrive at 2x, while my v prime, we differentiate cos x to arrive at minus sine x. So the next step is to substitute into the formula. What's my v? V is cos x. U prime is 2x, so it's times 2x. My u is x squared, and my v prime is minus sine x. And v squared will be cos x squared. Now we can go further in terms of putting the 2x in front of the cos x. So we're doing a little rearrangement. Then this negative times a negative gives you positive x squared sine x all over. We can still write it as is, or some persons like to write it as cos squared x. So if I have, for example, x squared over x cubed minus 3x. Again, it's in a fraction form, so I have to assign 1 to u, which is the numerator, and the denominator to be v. So my u prime in this case is 2x, while my v prime will be 3x squared minus 3. Now we're going to substitute into the formula. My v, as stated, is x cubed minus 3x. My u prime is 2x. My u is x squared, and my v prime is 3x squared minus 3 all over v, which is x cubed minus 3x all squared. Now, I usually say to my students, something like this, you don't have to expand unless you directly say you need to expand and simplify. But our aims now is to simplify what we have in the numerator. So let us expand. 2x times x cubed from indices is the power 1, so we add a 3 plus 1. So this is 2x to the 4th. 2x times negative 3x is the 1. So this is minus 6x squared. Then multiply x squared times 3x squared. But because of this minus, it will be negative 3x to the 4th. Then minus x squared times negative 3, that will be positive 3x squared all over x cubed minus 3x all squared. So the answer in this case, 2x to the 4th minus 3x to the 4th, is like saying 2 take away 3, I'm left with minus 1, which is the same as minus x to the 4th. So you wrap up the variable. Then we have minus 6x squared plus 3x squared to give you negative 3x squared, and it's all over, open bracket, x cubed minus 3x all. Now here we have chain rule where we differentiate inside and the outside. So if I have something like this, applying chain rule, we carry the 2 in front, right by the bracket, 3x minus 2. Then we subtract 1 from the power, so I'll have just to the 1. Then I differentiate the inside, so I'll have 3. So 3 to 6, so the answer is 6. 3x minus 2. And then I can go further to have it as 3 6s, 18x. And 6 times negative 2, that's negative 12. So if I have 4x squared minus 1 to the 5, then applying chain rule, I'll carry the 5 in front, bottom bracket, so we have 4x squared minus 1. Then we subtract 1 from 5, I'm left with 4. Then we differentiate the inside, so we'll have 8x, then multiply 8x times 5, so this is 40x, 4x squared minus 1 to the 4th. So if it was 1 over 2x minus 5 to the 3, then I have to rewrite this as 2x minus 5 to the negative 3. Then we go ahead and carry the negative 3 in front. Then I have 2x minus 5. Then I take away 1 from this, so I have negative 4. Then differentiate the inside, so I'll have times 2. So my answer is negative 6, 2x minus 5 to the negative 4. So we have sine to the 4, 2x plus 1. We can rewrite this as open bracket sine 2x plus 1 all raised to the power 4. Then we're going to go ahead and carry the 4 in front. Right, but the sine 2x plus 1 inside the bracket, close bracket, then subtract 1 from 4 and left with 3. Then we differentiate the inside, and remember we have a rule for this, where sine 2x plus 1 will be 2, which is coming from here, cos 2x plus 1. Again, you can revisit my channel where I differentiate using the common rules. So the answer for this is 4 times 2, that's 8 sine 2x plus 1 to the 3, then cos 2x plus 1. We can also have sine 3x squared minus 5 all squared. So in a case like this, we have to differentiate inside the bracket. Differentiate this so we have a lot happening. So we're applying chain rule on top of chain rule. So differentiating to x squared minus 5 all squared, we're going to have 2, then write out the 3x squared minus 5. 2 is gone because 2 minus 1, that's just 1. And then differentiate the inside, so we have 6x. Then differentiate sine, we get cos 3x squared minus 5 all squared. So multiplying these 2, 3, 6x squared minus 2 times 5 is 10. Then we have a 6x cos 3x squared minus 5 all squared. Then 6x times 6x squared gives you 36x cubed minus 6 times 10, that's 60x. Then we write about the cos 3x squared minus 5 all squared. So if we had this as to the 5th power, so if we had this as 2x minus 1 to the 5th power, applying the same rule, we differentiate what we have here using chain rule. So we have 5 open bracket 2x minus 1, subtract 1 from the 5, so I'm left with 4. Then differentiate the inside, so you have 2. Then differentiate sign, we arrive at cos 2x minus 1 to the 5th. 2 5s 10, so we have 10 2x minus 1 to the 4th cos 2x minus 1 to the 5th. And that's really it. Because we have this power to the 4th, we would have to expand this bracket first before we multiply it by 10. Please remember to subscribe and like my video.